I'm here in the south of France at the CNRS Center for Optoelectronic Fabrication and Analysis, a center that does both applied science and pure science. And I'm with Guy Libourel, who is a cosmochemist, who is a co-investigator on the OSIRIS-REx mission, who is actually holding, believe it or not, a few grains from the Bennu sample right there, from the OSIRIS-REx mission. How old are those grains, Guy?
So these grains are very likely very old. So they come from almost the burst of our solar system. So 4.567 billion years ago.
Billion years ago. And here, your colleagues are busy at work. We don't want to interrupt them, but we wanted to bring you in here so the readers could take a look at the instrument behind you, which is where you did a lot of this analysis, or the analysis is still ongoing, and the results will be announced maybe before Christmas. We don't know. But tell us actually what the equipment here does and what you're looking for and hoping to get from the sample.
Okay, here we are in a room of secondary electron microscopy. So this allows us to have a very detailed map of these tiny grains. You see the grains. You can see it here on the screen, where we can detail the mineralogy. And so this is our job, actually, to detail the mineralogy of this grain of Bennu, trying to make the difference between is it serpentine, is it oxide, is it sulfide, and so on. And so this will allow us to see if Bennu is resembling one of our meteorites.
And the main goal of Bennu, one of the main goals, is to determine how Earth first formed, correct?
Yeah, maybe to understand how maybe water and how organic molecules were delivered on Earth. So, by looking at this pristine object, we may make a better understanding of what they host, what they contain, and what they deliver when they hit the Earth. So obviously, long time ago, at the birth of our Earth.
And you were telling me that the mineralogy in this sample very closely resembles the photosphere of our own sun. So it's very pristine in that sense.
Yeah, so this is our way actually to make or to be sure that this object is very pristine, because as soon as it has the same composition as the photosphere of our sun, so this means that since it formed, it didn't evolve, didn't transform, and so therefore we have here with this tiny grain of Bennu some of the fossils of this early time.
And so you are actually this laboratory is only one of 4 in Europe. You said there's one in the UK, there's one in France, and I've forgotten the other 2 countries.
It's Japan and Australia.
Japan and Australia. Okay,
yeah. We are one of the labs that will be in charge of characterization of the mineralogy of this Bennu. Then we will go to other labs, one in Germany and one in France, in Nancy, in order to have more detailed analysis that will help us again to accurately determine what is inside this grain of Bennu.
And how long will you be doing the analysis? You received this sample a couple of weeks ago?
So we received it 2 weeks ago, and so then the experiment and analysis are running, so this day. But we will have the sample for up to next year, end of the next year. So we will have 1 year and a half, actually.
And so when do you expect to see the first scientific papers?
So we have already some interesting results because just observing this sample is already plenty of information, and so we already got some interesting data. But again, so we need to wait a bit in order to have this result public.
And this is, if I'm not incorrect, we've had samples from comets, but this is the first asteroid return sample. Is that correct?
Not exactly the first, because Japanese mission.
That's right. That's right.
Hayabusa 2.
Don't want to give them the short strip.
Brought back some sample. So from an asteroid, very similar, by the way, to Bennu. But yes, indeed. So the idea is to make some comparison between what we think about comet. Notice that we don't have any sample from a comet yet, and what we observe for asteroid.
I thought there was an aerogel sample from a flyby mission of a comet.
Yeah, correct. Yeah, it's
okay.
Correct. But it's tiny samples that already give us a lot.
Okay. So, well, we look forward to, thank you for speaking with us. We look forward to hearing more about this after your official results are made public. I know there are some things that you were not able to discuss, but I appreciate your letting me in to the inner sanctum of the analysis, and we look forward to hearing more about it in the weeks and months to come. Thank you so much, Guy.
Pleasure.